Oh, there I am. Small. There you go. Bigger now. Hello, everyone. Thursday, October the 16th, 2025. Yeah, time flies, doesn't it? How's everyone today? Who's with us? Let me check. We've got the comments here. Da-da-ba-bum. There we go. Who's here today? Zen. Hello. How are you? Hope you're well. Who else? Anyone? Anyone? That's it? Just the two. Oh, Dean. I got a message from you, didn't I? You asked me a question, didn't you? Okay, I need to remind myself. Yeah, I've consulted my spreadsheet and Vaso. Um, Kalispera, that means good afternoon. WT. Good, 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 good. Jess, how are you? So, Jess, we need to talk. Yeah, we need to have a chat about something. Don't tell anyone. This is totally between you and I. Oh, wait. I'm very well. Thank you very much. So let's see what's going on here. I'm not going to do as usual with the new format. I am going to do the housekeeping at the end. And what else did I want to say? Yeah, I'm very, you know, it's getting colder here, but it's beautiful. Blue skies and autumn colors. And I get very distracted by beautiful nature, as everyone should. Beautiful nature is a very good way to get distracted rather than, screens and phones and all that phony blue color that keeps you up at night. Okay, so I have consulted the spreadsheet. Not only that, I'm starting to get questions now from a fantastic source, which is the the Reddit Cinema 4D. So if you do frequent Reddit or anything like that, there's a fantastic community that was started by Sage uh, called Cinema 4D with a capital C, a 4, and a capital D, all one word. And it has over 20,000 members. And I'm starting to pick some of the questions. I'm starting to pick some of the questions from various users over there. At the same time, I'm frequenting a few Discord channels. Go on Discord, find Cinema 4D, and there's a Cinema 4D procedural, and there's some 3D communities there. So I do frequent some of those. And of course, you can use the forum, which we are trying to update. Anyway, I've been talking long enough. I've wasted approximately 4 minutes of your valuable time. So let's get to the questions, all right? And let me go. First, I'm going to go to the chat. And as usual, please, 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 please type this question before you type a question so I can distinguish it from general comments, compliments, and all that beautiful stuff. So let me bring up my screen. There we go. And at some point, I'm going to do my little photo booth so we can use it as a thumbnail. So let me check out. There was a question by Dean Mellis. What is the best way to start making a capsule? The way you did the lofting of trace splines and all that kind of stuff. Okay. So let me give you a quick, just a bit of an introduction. Because what Dean is talking about is creating a node asset. The word capsules is reserved for anything we put in the asset browser. So anything that's distributed by Maxon, whether it's a texture, whether it's a tool, whether it's animation, it's motion, it's all that. We name those capsules, even for products that are not Cinema 4D. So anything that is Red Giant and so forth, anything that comes as a preset or something like that is a capsule. So let's distinguish. We're talking about a nodal modifier. So if you go to nodes here and go to asset construction, The ones you can make currently are nodes mesh, which is a generator, a nodes modifier, which is a deformer, and node spline, which is a spline. And those are the three ones that we recommend right now. So let's assume you want to make some sort of loft. So one of the things I did the other day, and what is good about this is that you can programmatically do something that cannot be done using other tools. So first, you need to decide how you're going to implement this. If it's going to be some sort of generator or a modifier. That could be interchangeable. So you can make something that is a modifier, and it can also stand as a generator. The choice for that will be how you will like to use it. Do you just want it to modify some existing geometry or an existing spline, just like any of the deformers? Or do you want to be able to get a copy? Let's say, for example, you can get a copy of an object and use this to create something else out of it. And let me do a very, very quick, silly example. I'm going to get a figure. I'm going to connect it just to make sure that we don't have any issues. And I want to make a nodal asset that creates a copy of this, which is smaller and a bit offset. So we're going to call this my mini-me, right? Having good ideas and writing good names is a great way to do these things. Okay, so let me double click on this. It will bring this up. It's good to have a dedicated nodes layout to do your stuff. And first of all, how do I want to bring it in? And I want to bring it in as a child. Will be just like other generators, like the extrude spline and all that, or you can bring it as a link. The good thing about the link, if you open this, you'll see what can come in, is that you can have a copy of your object. So if I drag this in here, and all I'm going to do is use a transform geometry. I'm going to take me, there you go, we have a copy, and I'm going to make mini-me by making this and putting mini-me right behind me. There you go. So now we have the mini-me generator. And anything you link here will get a copy that's half the size and slightly offset. So having a genius idea, just like I thought, and a great name is the best way to start. But joking aside, this is, the first step to decide what do you want to make, why do you want to make it to work that way. From that point onwards is the hard part of the question. So let me show it up again. The best way. Well, you will use these tools if you want to solve problems, right? That's the best thing you could do. Let me give you an example. You could go, so let me show you something that's already doable, but maybe you want to implement it as a tool. So let's say you have this editable object and you want to delete the caps of cylinders, of many, 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 many cylinders. So what I'm going to do is I'm going to make copies of this. Imagine that these are 72,000 cylinders, right? So let's go and connect this and make it editable. There you go. So now we have one object, and I want to delete all the caps. Before you start creating any kind of tool, you need to ask yourself, what I'm planning to do, is it something that can be, let's say, codified, make it, describe it algorithmically? Okay. So the question here is, if all the caps, what is the common thing between all these caps, right? I'm going to give you about 30 seconds for someone to reply. What would be the common thing, something we can tell the computer to do for us when it comes to these caps, to identify these caps? Let's see if someone can come up with something. Let's see. I'm going to give you a few seconds. Bring up my face, say hi. Hi, everyone. So let's see if anyone can come up with a good question. So the question is, what is common between all these? No one is paying attention. Come on, come on. Put on your geek hats on and tell me. I'm looking at the chat. let's see. Tries is 1. So Dean says tries. That's 1. Okay. But that's a component. Yeah, it could be the tries. Okay. I'm going to tell you what is that one thing that distinguishes all caps from the others, is that besides being comprised by tries, is that they all have the geo. Yeah, Tobias says the geo. But what about the geo? They all have a point that has more than 4 connections. So everything is a quad here and has this. So this point connects to the rest of the geometry using 1 edge, 2 edges, 3 edges, 4 edges. This one here, 1, 2, 3, 4. The only one that has more than 4 is the point which we don't want. So for this example, if we could go and select all the points that have more than 4 connections, we can actually select them and delete them. Now you can do this manually. You can go to your, let's go to the mesh checking, right? And in the mesh checking, you can check mesh, and there's something here that complex poles, and you want an edge count that has at least 5, okay? And you can go and select these points. So, you know, you can't get 1 or 2. The minimum is 5 for reasons, because a complex pole, by definition, needs to have more than 4. Anyhow, I wish we could select it for an arbitrary number, but hey, no one listens to me. So now we've selected them. We've selected all the points which are complex in the sense that have more than 4 connections. So now I can just press delete and delete them. That's it. I'm done. Now, you may want to create the same principle using nodes, because you don't want to go to that tool, or you want to apply this to a number of procedural objects. And that's the great thing about using a modifier or a generator and so forth. You don't have to rely on this. You can do this live. And in this particular case, a modifier would do a good job. And from this point onwards, you have to figure out how to get the geometry and what we are trying to find. And that is the learning curve, which is now the next step. So how do we know how many points? Well, there is something called a neighbor. So a geometry neighbor. And you can select for points and which index, and it will give you the indices of the points. So the way this works is for any given point. So if I select, allow all these points to see their indices, for point number 575, it will return this little thing will return a little array with the indices of everything you see here, 635, 630. So get a list of all these. And basically what you can do here is get your geometry and just start going through all the points, and get the count of this. And again, these are now things you need to understand how to do. But the great thing is, once you do it, you can make it once, and then it's a tool. So you get the count, then you have to do some, you have to compare this. So compare, and you have to, let's go and compare, compare. There is the compare. So you need to compare the count, which is an integer, although you don't have to change it. The system is smart enough. But if the count is greater than 4, greater than is more than this number. So greater than 4 means 5, 6, 7, and so forth. Then in that case, if this fires a yes, because the blue one is a Boolean, and if you click here, you'll see. So this is a yes. A yes is a 1. You want to do something with the point which that does have more than 4, and that will be, let's say, deleted. So you would go and you would work on this in a certain way. You can actually loop through all the points, or you can create an array with all these points and then use all those points to delete them from the whole geometry. So now you have to do things like you need to get all the points. So I'm going to get the points info here, get the geometry, because we have all these points, and I want to take the point indices, and it's going to put an iterate collection. So it's going to go through all these points. And for each and every one of these points I'm iterating, you don't need any of these things. So this is creating a little loop, and you're going through this loop, and you're saying append, and the mechanism is by your building a collection of indices which we want to remove from the totality of all these points. And that will be a delete. So you're going to delete points. And if you right click here, you will see that you get an input which says selection. It's not this selection, it's this selection, which is an array. And basically, I want to add to an array of integers. So you need to make sure that this is an array. These are, unfortunately, the things you need to learn to do. Once you do it, if you do it one time, you're going to know how to do it for the next time, looping through these things. And there's some great resources. Donovan Keith has a YouTube channel that talks all about these loops and arrays and so forth. I'm not going to finalize. I mean, let me take it a couple of steps further, and then we'll just move on to other things. So an array of integers. I'm showing you some of the ways you can do this. The geometry we're trying to fix is this. We're trying to change is this. It's connected up. It deletes everything now. We don't want to delete everything. So I'm going to create an array that will add only when it's over. So when it's more than 4, it's going to say yes. So it's going to hit a 1 here in the count. If it has fewer than 4 and fewer, 4, 3, 2, 1, it's going to say no. So it's not going to add this number. But what are we adding here? Well, we're adding the index of that point, or the indices themselves here. And if I put here this, let's see what's going to happen over here. So what is it deleting? It's deleting something which, let me see, because I probably fumbled this. Points info. Get the points. Let me see if I need to put indices here. No. Yeah, I kind of fumbled this. That's why I don't like to do all these things all the time. Or maybe. And delete unused vertices. We have points here. Oh, interesting. I've deleted. Yes, I had the object selected. See, there sometimes I get sidetracked and confused by the simplest things because I'm in points mode. But essentially, this worked. There you go. And let me get rid of the numbers. So I did everything correctly. So essentially, what's happening here is that we're just going through all the points of our geometry, creating a loop. So iterating through these. I'm using the point indices as my looping iteration, all those numbers you were watching before, and I'm telling it to find the neighbors. If the number, the size of each and every one of these arrays, what we call the count, is larger than 4, then please add the number of that point, because that is a point we need to delete. And when everything has been collected over here, if you right click and say data inspector, we should have all the indices of the points which we're going to delete. And this array, you dump it in a selection and it does the operation you want. So what I did before, although one thing you always need to remember is that I personally prefer to spend 10 hours to find an automatic way to save 2 minutes. But if you don't do that, where's the fun? From this point onwards, it doesn't matter how many of those we have, and it's automatic. So I have this as a tool. I can save it and have it in my arsenal, and I don't have to go here anymore and do mesh checking and all that nice stuff. Plus, I can give it a nice little interface and so forth. Anyhow, in the last 15 minutes, we went through 10 or something like that. We went through the process of thinking and designing an actual tool based on a very specific need. I have done this in the past, and I have used this because of a very specific reason. You can do other things as well, but I think I'm going to conclude this part with this. So that was a sniff into the world of creating node assets, capsules. You do need to learn certain things. You need to understand the structures of each object, what they do, the limitations. That's another thing. Now, if you have very specific questions, feel free to ask them. But one thing is, we are trying to find a way to create some sort of material. The problem is that we want the material we create, the tutorials, to have a good shelf life and to apply to a large majority, a large number of users. So that is where it's a bit of a balance. But in any case, you can make more of these. And that's the great thing about these tools. And from this point onwards, it can be applied to procedural objects as well. That is the great thing about doing it in this way. You can just add more and more and more of these, and they all don't have caps anymore. Okay, excellent. Let's see now. Boom. What do we have here? Oh, friend Drake. Hello, hello. Design motion designers. Indeed, that is a good one. Motion designers. Okay. Let's read another question. Then I'm going to go to some interesting stuff. I'm going to go to flying bills here. Money. Imagine greenbacks and all that nice stuff. We're going to do roof tiles, procedural roof tiles. We're going to do opening a weird DWG file, animated hoses and things like that with, yeah. And what else are we going to do? Yeah, that's what we're going to do. Okay. Mini-me. Bye-bye, Mini-me. And I'm going to close this. Actually, I'm going to leave it just in case someone asks a question. So let's go on to another question. So, Mohammed, I'm really new to 3D. Welcome to our world, especially simulations like cloth and so on. If you could choose one to upgrade, which one would be better? The GPU, CPU? Prioritize having more cores and thread. Yeah. Well, what I would say is any gaming CPU with, let's say, 16 cores or something like that, something that is acceptable with a fast single core process. So when you buy a CPU processor, as far as I know, the single thread performance is very important, the actual speed of the processor, because a lot of the things that games do are single threaded. And it's very good to have a quick, fast single thread processor. 16 cores now for general, because a lot of stuff in Cinema 4D is parallelized. It is multi-threaded, and more things are becoming multi-threaded as we go. Not everything can become, but I guess the developers are going to push it as much as they can. So you can have a decent gaming processor. You don't need those massively expensive Pro 96 thread. No, because we're not rendering on 96 cores, and you're going to have diminished returns. Then you put your money in a decent GPU, and I would say, in terms of, let's say, NVIDIA, even if you don't go for the 90, so the largest tier, the 80s would suffice. Or you go to a previous generation, you find one that has been slightly used, and still has juice. My computer here, the one I'm using, is a Dell workstation that Dell very kindly provided me years ago. And it's got a RTX 5000 with the 16 gigs of VRAM. And as far as the speed is concerned, it compares to a 2090. It's slightly slower than a 2090, or around that speed. Sorry, but for that time, it had more RAM. So it was a professional card, a workstation card. And, I get by. I do have a laptop with a 4090 in it, and everything is faster, and it still has 16 gigs of RAM. If you can afford it, get something with more than 16 gigs of RAM, although you can. So that would be my general advice. That would be my general advice. Okay, let me address some of the nice little questions. So the initial question I got here was, okay, and it was referring. So this question is from Will Nash, and Will asks, it's on my spreadsheet, so I can't paste it yet over there, but doesn't matter on the screen. This is based on someone else asking a question about making bills and how you'd make them particles and so forth. And the solution I came up with very quickly using particles and such is something like this. Yeah, we can avoid the penetrations by making these emit over a larger distance or something like that. But you can see that the behavior is not bad, and we can play with the stiffness and all that. So let's quickly go and do this. So in a new document. So let me bring this over here. Let me add a new document, and let's go simulate and create a basic emitter. I'm going to make it a bit smaller and like that. There we go. And I want to emit few particles. I'm going to say 5 per second, right? So let's check them out. There you go, 5 per second. Good. And excuse me. And for all intents and purposes, I'm going to use a cloner, and I'm going to make a bill. So let's make bill here. It's put 4 and 4, and I don't know how big a bill is. You can make things slightly bigger. Just find the ratio, make sure the ratio is correct. And there you go. Let's say this is a bill. And because I want them to be rather stiff, I'm going to use few subdivisions. If you go to Cineversity and check out the tutorials on cloth I made a couple of years ago, I do talk about ways to stiffen up your simulation. I'm going to have a sip of coffee. Cheers, everyone. And I'm going to make this a child of the cloner. And I'm going to tell this that I want to emit on the particle group. So object and this. Okay, so there we go. So now we are firing out these monies. Good. So what I want to do, first of all, I can get rid of my speed and all that, because everything about this is going to be taken over by the simulation. Add a few frames here, 600. So let's go to the cloner, right click and say, I want to make this into a cloth. And you have to put the cloth tag on the cloner when you're making many copies. And each one now is going to be a little piece of paper. And it looks, this is, I think, the point where everyone gets to and says, but why don't they look like, floating around and all that? So let's start by making a nice little floor so we can catch the money. We don't want the money flying away. Let's make this a collider, make it invisible. There we go. Just put it here. And we want to fix this problem here. Bonk, bonk, bonk. Good. How do we fix it? Well, if you go to the cloth, you will see there's a tab called Forces. And as of a couple of years ago, they added drag and lift. And these two parameters have to be adjusted together with the mass, because the mass is the mass per point, and it tells us how heavy each one of our bills is. So these are little carpets, little rugs, okay? These are definitely not made of paper, but if you go here now and remember, I went here and I increased this to 100%. I'm going to blow them up to a huge amount. But just for now, let's go to the surface and let's make this 0.01. Whoa, look at that. So already now, because of the lift and drag, we're getting something. Now, because mathematically the cloner is creating totally flat pieces of whatever this is, they don't twist around because look at them. But so you saw what happened. They collided, and that collision made them fall down in a different way. So let's just tell the cloner to add a bit of rotation. So let's go here, parameter. Let's add. Actually, I'm going to add a random effect. Go here, MoGraph, random effector. Turn this off. Go to rotation, and let's find one of the rotations I want to emit this. Let's see. There you go. So now they're emitted with a slight little rotation. And from this point onwards, now you have these little random. Let's make this 90, 90, 90. So we get all sorts of different. There you go. Some of them fall like that. Some of them fall like that. If you want them to be more floppy, you add more subdivisions. If you don't want them to be so, to be so vertical, you can say, okay, I'm going to make it 45. So some of them are leaning this way, some of it leaning that way. And now you control how much they float by going here and now and increasing the forces. Because the mass is, I guess, zero mass. This is the smallest mass. And you can see that now we're getting this sort of these autumn leaves sort of thing. So let's add one more. There you go. There's your money. So just play with this, or you increase, you make this larger and you go and increase the forces. So you can make this 500 and 500, and you can separate each, have less drag and more lift and so forth. But in any case, this is how you would go and make more realistic money that falls. And don't forget, if you're getting penetrations and all that nice stuff, go simulation, play around with these settings, and yeah, good luck with that. Show me what you're doing. If you want them, again, a bit more floppy, just make sure you go to your plane and you add, let's say, 8 and 8, and rewind to get everything to start again. So now, because we have more subdivisions, they're going to be a bit more floppy. There we go. And that's it. What I would actually not use flat. I would use different models. One of them with a bit of a kink here, another one, just to add a bit of variation. But that's what I would do. So flying bills, this is exactly what I did here. And this is the result we get. Okay. Let's see now. What else do we have here? Let me mark a few things. So first of all, let's start with Pixwolf. Hello, Noseman. Hello, Pixel Wolf. Oh, should I do that? No. Can I make a transparent liquid behind a glass object, such as orange juice in a bottle? Tried using Puzzle Mat with fraction ID. Ugh, no. Yeah. Yeah. You will have to do a separate render scene for this. If you want the pure mask, you cannot do it in one pass because you have other objects in front. That's the whole point of this. So you would have to set up maybe a take or something like that, or just a new scene, and make sure you make your glass non-renderable. And the only thing that you render is the cached liquid, and that will give you the mask. Sorry, I didn't have a better response for that. Okay, let's see. Really like how incredible simulation in cinema are, especially the cloth simulation. It is, yeah, it's interesting. All the simulations are interesting, and you need to learn to work around the limitations of any simulation technology. There's no simulation technology that is flawless. Okay, let's see. Jess, I've been trying to pose morph a flat pattern piece into its own shape from Marvelous Designer. Both have same point count. I see glitches morphing. Tips on these for the pose morph tag. This is a let's see the context first of all. Same mesh piece, just exported once when it's flat and once after it's been sewn, both glitches. Yeah, but you need to make sure that both of them have exactly the same topology. Bring them in side by side and check and see if all the points are in the same positions. But this is something, send me the file and let's check it out, because this is ideal to check the actual file, because there could be some nuances about it, some details about it, which are not 100% obvious. But yeah, so please feel free to send me a file. We can talk about this. And generally these kind of things, we can find something that it appears interesting for the general user base, and then on the next show I can show something like that. And as usual, it's a great pleasure showing some of your amazing stuff anyhow. So you're doing us a favor. Okay, let's see what else do we have here. Boom, 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 boom. Vaso, whenever I use takes and link a camera to a take, hitting the control key always take me back to that camera view. If I'm out of it, I did not know that. If you feel that that is buggy behavior, that is something you need to call customer support and open a ticket, because it could be something we're not aware of. But yeah, because I mostly teach and I don't use it, my use of takes is more on the instructional side. I don't use it in production, so I may not be aware of some of these things. Okay, let me show you a few other things. I think this is going to be interesting. Okay, what I want you to do, I want you to observe this. So this is some sort of Japanese style tile, and the challenges here was to find a semi-procedural way to put them in place so that they are parallel. Only the ones on the surface. That's the original surface. I can turn off my cloner. The surface is not straight, so these need to sort of follow the contour of this, and only the ones that happen to be on this be visible. So that was the challenge. It's harder than you may think. It's one of those things where it oh yeah, I'm just going to use a cloner. No. So let's copy the roof and the tile, go to a new document, paste them in here. Okay, so I have the tile somewhere over here. I just made it using 2 cylinders, right? Okay, and this is the object here. Now, the original model I was shown didn't have regular topology, but you can always fix that. And having regular topology for this will help the solution. So let's begin with the first thing. I want to clone on this, and I want to clone a regular grid. So if I grab a cloner and tell the cloner I want to clone on this object, it ain't going to work, because what are we trying? So surface here. Okay. The surface, though, is going to randomly generate. I don't get that ordered thing. I want them to be aligned, like little soldiers. So any of these, polygon center, no, won't work. Surface volume, axes, edge, nope. It won't work because these tiles, these polygons are not even equidistant. Okay, so this will not work. This kind of cloning. What we need to do is, first of all, one step at a time. First, we're going to create a matrix object. Now, for many of you, you may not know why the matrix object was historically introduced. Every few years, I do a presentation or a lesson, and I mention this because that information gets historically lost, and it's very important information. The matrix object was only created so that when we deform a cloner, let me show you what I mean. I'm going to take a little cube that is 50 by 50 by 50, and I'm going to clone it. Now, if I take this and I bend it, what's going to happen? What I'm bending here is the geometry. The cubes now are changing shape. Okay, and if the cubes have subdivisions, you're going to see them bending. Okay, what if I want to bend only the matrices? That is the reason the matrix was created in the first place. It was created so that you can take a matrix, apply a deformation to it, and then use that matrix, that deformed matrix, to clone object on the matrix, to clone your little cubes on that matrix. I'm going to make this 5 and 5 and space them out. And what you see now is that the matrix is deformed, but the cubes are cubes. So knowing why the matrix exists in the first place, the main reason the developers created it, is this. Because now, instead of worrying about deforming the geometry, we're actually deforming the matrix. Internally, and this is now trivia number 2, internally, if you make a matrix editable, it's a point object. And it contains, for each and every one of the positions, it contains a point where the cloning occurs and 3 other dots which define the matrix. Now, I'm not going to go more into this, just to mention that this position, scale, and rotation, all these 9 values, can be encoded in a 3 by 4 matrix with values from 0 to 1, and more if we do certain things. A rotation, position, and scale. And that's the point of all this. This is internally a point object that gets deformed, and then we can use it to apply our clones nicely without any deformation of our geometry. Okay, so we're going to do this. We are going to deform this, but we are going to deform it so that it conforms to this weird shape over here. So what I used, maybe there are different ways of doing it, but what I used is a projection deformer. Put it as a child of the matrix. Make sure that you are projecting downwards. There we go, 90 degrees. And let's tell it to project on my roof. Parallel. And let's see what we get here. We need to raise it up because it needs to find the object underneath. There you go. So bring it up. Excellent. And now I can use this. I can change the values, depending what I'm trying to do. Now, it is doing something odd, but you can see clearly that it's sort of cutting a window over here and projecting everything downwards. Okay. Now, if for whatever reason you want to project slightly sideways or, rotate the whole thing, you can go here. You can rotate from whatever angle you want. But you understand the concept of this. Okay. I'm going to leave it as it is right now. I can do this. Whatever. Good. We can change this. Now, for everything that I don't want to see, I can actually go and make them invisible as well. And I'm just going to use a nice little trick. I'm going to use a plane effector with nothing on except for visibility. And in the visibility, I'm going to go to the fields and drag the subdivision thing. And let's see, subdivision, and use surface. And that should work. Do I need to invert this? Let me think for a second. I think. Let's think. It worked when I did it earlier, so of course it needs to work when I do it now. Let me very quickly turn off the visibility and check and see the position. See if, okay, it's not doing anything. I put the subdivision surface in here and surface. Oh, there we go. Okay, it's the original position of the matrix that is trying to to view. So all I need to do is just make sure that my matrix is a bit closer to the object over here. Yeah, that's what it's trying to do. Move it a bit closer. And let's see now. So it's moving those up. Let's see if visibility is going to work now. So let's do that. Make sure you can see everything else is raising up. Visibility. There you go. And I can sort of truncate this a bit. But you can see that I'm controlling how many of these I'm seeing now. I can bring this even closer. Let's go somewhere here. I don't want it to intersect. Boom, 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 boom. Go. And see if I need to do this. I'm pretty sure we can grow this a bit, but I'm going to stick to the others. You can just move it around and find the perfect angle. I have it somewhere. Where was it? Where's my file here? Roof tiles. In this particular case, what do I have? I have the matrix up there, and I have my plane visibility with the subdivision surface, 11 from the surface. So it was, yeah, it just worked. So let's go. Where are we? Over here. And let's do that. Now, let's go to the cloner, and now I'm going to turn it on. And for the object, I'm going to use the matrix. Okay, right. If you really want to, make sure that everything vanishes, you can always go here and add a linear field. And let's make sure that this linear field is aligned in a certain way. There we go. Let's make sure that we get the, is it max or multiply? Move it up and make it thinner. Is it multiply, or do I need to make plus y? Come on. Oh, no, it won't work that way. Let me think. No, because these are the ones that are moving. Darn. There we go. See, they were in that position anyway. So I think it's my mistake. I hate it when this happens, when it's the minutia of the values that make this not work. I just want things to work. I just want things to work. So am I asking too much? Just want things to work. So now let's delete this, and let's go here, and let's go to fields and select this, and let's increase the value, its surface, and outside. Oh, I think it's the outside or the inside. Let me think. Oh no, no restrict selection, and use the formed object. Why can I not? Yeah, everything is, it's just the placement. That's it. It's just causing, all this is happening because of the placement. Anyway, let's increase the size here. And let's put the tiles, so you can see now the tiles are a bit out of sync with what we're seeing here. So we need to align now the tiles to the surface. And, that sometimes it appears, let me bring these closer so they kind of overlap a bit. And I'm going to fix them in a second. You can see that they're all parallel. They're not following the surface. What has the surface information is the surface itself. And the way to make objects orient themselves in a very specific direction is using a target effector. So essentially, we need to take this cloner here that is using the matrices and add a target effector to it. So let's go MoGraph. Let's go target effector. There you go, target effector. And the target effector needs to be in field direction. And in the fields, you need to drag the subdivision surface object. And there are a few other things you need to do here. You need to make this plus X. And yeah, of course, nothing is going to work now because I need to refer to my original. Right, let's break this down. Roof, what have I put in there? Fields, the subdivision service object. I put the subdivision service object in here and it works. And we need use pitch, reverse heading, and plus. That's what happens when you play with the values. Reverse heading plus X. Why is nothing working right now? Oh my Lord. Everything is all over the place. And I hate this. I hate the surface. Yeah, yeah, total brain freeze. Total brain freeze here. So the matrix, matrix. Oh, I added it to the matrix as well. This must have happened by mistake, and I didn't expect this to have any effect. It shouldn't have any effect on the matrix. I do apologize for this. Just it does make a difference. Holy moly. So I just need to revisit this, I guess. Yep. I need to revisit this and do some sort of clear, more clear tutorial. So yeah, at this point, I'm going to apologize for the mess because things worked and now they're not working, and that's because 100% I'm doing something wrong over here. Yep, and the idea being that I'm trying to get the normals from this. So let me drag the normals in here and see. So what you're seeing, let me show you exactly what I did here. So um, the matrix just has a plane, forget about that. The cloner has a target loaded. In the target effector, instead of using the subdivision surface object, I'm going to use the normals of the roof. The way you make the normals is you go to your um, the font tag and you say create normal tag. You need a mesh object to do that. And that's going to take the normals from this object here. That data will be read properly. And you can see it's creating. Let me turn off the matrix. You can see now that these are nicely following the surface. And of course, I can go here and tighten them in the z-axis. So they do fall on top of each other and they interlock. And other than that distance thing with the matrix, this is pretty much the secret sauce for something like this, to make sure that the data you're using to make them orient themselves is the data you know you can take advantage of. So why is this working with that subdivision surface object? I do not know. Anyway, it also works with a normal, and that's the proper way to make it work. But in any case, I think that just the understanding that you can use to orient things on surfaces, the object normals, and the target effector. Make sure the target effector is in fields direction, and you play around with these to find exactly what orientation you want them to have. And I always go through these and just play around. On top of this, you can go, pardon me. On top of this, what you could do is just go and add a bit of an extra rotation, the plane rotate. You will see that if this rotate doesn't exist, they kind of fall onto each other. You just add a bit of rotation on top of that. And, just you can see that way, or you can add some this way, just to make sure that there's that cascading sort of effect. And I guess I will call this a successful setup. Managed to orient them. Okay, let's see if there are any questions over here. Um, One sec. Don't deform object. Why? Why not? No, the projection deformer is not breaking the target effector. No. It's as you can see, now it works. So I guess it was when I was messing things up. What else? What do we have here? J, but also it's moot because roof tiles are straight and independent of base topology. Well, that's the point of all this exercise here. So let me just close this and let me close this. So the whole thing about this exercise is the objects themselves, the tiles themselves, are not deformed. These are all identical. As you see here, they're all identical. And this is how you use tiles. They're all identical, and you just cascade them on top of each other in a way where you go then here and you put a different type of tile just to cover the corners. But anyway, so this is the combination of things. And I would say that the highlight of this is to make sure you know where you can get the data you require. As far as the, the surface slope, the normals of the original object is the best way to pick these up. Okay, good. Let me do one more thing just to show you something in case you didn't know it. Just because I'm here. Let's assume that we have this and we want to subdivide it. This is for anyone that doesn't know. If I subdivide it, we're going to get these rounded edges. If we want these to be sharp, you go and you select your 4 corners, the ones you want sharp. And basically you press the full stop, the dot on your keyboard, and you drag. And this will add a subdivision surface weight tag. You can add it manually if you want. And this will allow this to be subdivided, but it won't subdivide the corners. So you can retain the shape you want. You can do 3 and 4 or 2 and 1 while keeping these corners. So that is the trick to do that. That exists somewhere in the manual anyway. A good question. How can I find this tutorial in the future? Well, that is what I need to figure out. Which one of these tutorials? I've got a few in the pipeline. Yeah. So, flying bills, we did that. Any questions on flying bills? Creating your little thing. Oh, let's quickly go roof tiles. Bye-bye, roof tiles. Now, let's go to this. This is an interesting one. So someone sent me a DWG file with some topographical information, and it wouldn't open in Cinema 4D. And I'm going to show you because this is something that may happen to you as well. So I'm going to drop a DWG file and whatever, reset to default, whatever that is. Just press OK. And we get an empty scene here. Okay. Cheers. So, oh, there's a nice question by CG something. I'm gonna mark it here. You there? Okay. So you can't see anything here, and there's sort of a reason for this. So if you select the object, whenever you expect things to happen, but things don't happen. So you see one object, and then you open it up, and it's got a million objects. If you middle click, we have 2004 elements. Oh, 2004 was the year that Greece had the Olympics in Athens, and the Greek football team beat the Portuguese team in Portugal twice. I guess this is for my very good friend Pedro, which I've been reminding him for the last 21 years about this. Anyhow, when you don't have many successes as a football team, you have to remind the good ones. So you can see here that we have a lot of elements. Nothing is visible. But if you open up your coordinates manager, holy moly, we've got 255,000 something centimeters. And here we have, what is it? Is it million? 2.3 million. So there is stuff here which is very, very, very far away from where we are. Now, there is something you need to know about being far away. First of all, let's go to the scene settings, Control D, which you'll find somewhere around here. So scene settings, and go to the scene, and you will see that in the display down here, we have view clipping. So let's go to huge view clipping. Oh, there's something. So I can't even zoom in. You can see these are mysterious things going on. Oh, I can see something. Let me go close. Look at this. I can see things. And if I go close, you see that there are things, it gets clipped. And when I navigate, look at all these weird flickerings and stuff like that. Can you all see these little broken lines and all that? So the viewport technology for a lot of 3D software, when it has to take into account a very large distance from the origin, weird things start happening in the viewport display. These jump around things and so forth. This is not a fault of the file. So we need to fix this, right? And the way to fix it, first of all, as far as I can tell, well, that's so far away. That is, how far away is that? It's a lot. I need to bring everything to 0, 0, 0. But there is this null here, press H. There's this null which resides in the center of the world. And maybe there are others as well. So I need to find these. That means I need to do some investigation here. What I'm going to do is delete things I don't need. So I don't need this object. If I want to delete it without affecting the children, you can always right click and say delete without children. It's a very handy command. So here, delete without children, delete without children, delete without children. There it is. Delete without children. Boop, it's gone. But you can see here, we still have something. You see there's a little dot here. So I'm going to click there, go here and press S. Oh, there's another one here. And it's got some children, which is on 0, 0. And then it has all these lines. Holy moly. So what I'm going to do is select the line and say, go to Tools and say, and that's because I don't know if someone is using this as some sort of reference, some sort of instance and stuff like that. I just want to make sure that these lines here and this happen to be in the same place. So select the child, which is here, and go to your tools and say center parent to. So it's going to center the parent of that object to itself. Then select this and do that again. Go here, tools, center parent to. So now everything has been moved over there. I don't see any dots. Okay, let me select everything. There you go. Everything is here now. So with everything selected, I'm going to go here and type, which is the average of all the selections, 0, tap, 0, enter, press H. Now everything is in the center and nothing is flickering. So let's do the last thing. I have a huge scene, Control D again. Let's go here, make this medium. Now I have everything I need and everything is here. Okay, so something that appeared to be broken, in fact, it's not broken. It's just that things were placed in such a distance from the origin that caused this to appear broken. Now, one more, this is I would say, the long way to solve this problem. There is a shorter way. This is the same file just opened in Illustrator. So sometimes, just sometimes, it may be worth, before you open something in Cinema 4D, if it's one of those formats that are two-dimensional, open it in Adobe Illustrator. Check it out to make sure that the file is sane. And then, because we have all the layers and all that, you can simplify it and export it for Cinema 4D. Or create an Adobe Illustrator file and open that in Cinema 4D. It's going to open up the layers and all that nice stuff. So that is what you can do with these kind of files. Let's see if we have any questions for the time being. Let's see here. There was about the previous. We can also do that parametrically by choosing OpenSubDiv edge and corner option. Yes, you could do that. I was talking about the manual thing. So what Jay is talking about is that, let's go here, and you have a plane and make it editable. You can see if you want to round this And you can go here and you can say OpenSubDiv and bilinear. There you go. So it just keeps the corners. And another thing you could do is you can pre-subdivide things, and in case you didn't know that. So it's a good way of doing things. Okie doke. So that will be the suggestion. Let's go. Next one. What is this? CG and thingy madoodles here. How to transfer particle or pyro voxel data. Wait a minute. To MoGraph objects. Okay, that's not age and so forth. Well, the age is automatically, so to speak. Color. Let me quickly show you. I think it's. Let me ask a question. Have you watched all the tutorials on Cineversity? Gonna ask. I'm gonna show you anyway. Let's see. Let me show you here. Let me close this. We can go to that later. Ooh, we passed 12 o'clock. Okay, let's assume we have, let's go and do age. Okay, so let's go and do a basic emitter, and there we go, a basic emitter. And if we want to get the age. Now, if we create a few particles, there you go. And go here and do a current state to object. What you will see is some of these is age, right? So there you go, the age, underscore age, and so forth. So the age exists as a vertex map, so to speak. So do you want to do it for the MoGraph object itself or another MoGraph object? Let's go with a matrix and let's do this and put it here. Let's just see what happens when I do this. I'm going to go and colorize these. So let's colorize these using particle group, and it asks you, what do you want to use here? I want to use the value source or the color source. I want the color source to be the custom property, the age. Yeah, where is my a? No, I don't want a custom property. Color source, the view. Okay, value source. I'm going to bring in the age, right? So that is the amount you're going to get in here. But I want to transfer it to the color. So you need to use a channel convert. You need to take whatever you're doing here and convert it. So color, we want to read the value. See if that's going to work here. And move the value. Let's see if it's going to work. Are we going to get? Am I applying this to the matrix? Applying this to the matrix. I'm using the plane effector to read the particle group's value source is age. Good. And let's use both of these. So let's see, let's make this larger, 200, and find out what's going on here. Let's see if it works without the child convert to begin with. Okay. I want the value source to be age and the color to be color. Yeah, everything is green. That is correct. Let's go to the basic emitter, and in the properties, let's put a random color, and let's go. There we go. At least to know what we are looking at. And this is based on proximity. That's why the parts that don't have particle close to them, you can see they get the color from the closest particle. So we need to change that. Go here and let's say clip to shape, or not nearest. Let's go. Yeah, I think clip to shape is min max. I think that's even better. So you have your radius here, and it mixes up all the average colors, right? So now only within that distance you're going to get some sort of change. Okay, so we are getting the color as color, but you want the age as color, correct? So we are getting the age as value, and then the channel convert should allow us to use the value, which is now the age, as the color. So let's see if this is gonna work. Normal. And for reasons I do not understand, it's not working. I am converting channel and I'm using the color direct. No, nope. The red color, getting it from the value, which should be, that is interesting. I should be getting the, I want the value from this and I want to transfer it to color. Yes, I need to investigate because I haven't done it for a while and maybe I'm doing some sort of mistake, but I would assume that this will take the age. Oh, unless, okay, but the age is a number in seconds. Let me think about this because maybe I'm doing some weird mistake because the age, if it's 1, this is going to be white, isn't it? Let me move this very close and see if we get any other colors the moment they're born. No. So I need to check this out, but this would be the general process of how to do this, where you would get whatever you want from your particle. You can see that you can get the colors here, and you use that. You can use a remapping if you want and remap it. So let me do it in a different way, just to offer you a solution. In this particular case, I'm using the random color as the colorization of this. All right. So let's assume you want your color to be based on an age. All I have to do is use a color mapper and map the age to some sort of color. So I'm going to go to my simulate. I'm going to get in the modifiers a color mapper. Let's put it here. And the color mapper, you can see I'm going to take the age, let's say from 30 to 60. All right, only from 30 to 60. And I'm colorizing the particles. And because I'm colorizing the particles, it's going to colorize the MoGraph as well. So I'm just using a different way without doing it directly. Okay, so let's talk about the Pyro stuff. I do have a tutorial that shows how to get Pyro. Let's see, tutorials, where are we? CG something something. You didn't reply. Have you watched the tutorials? Pyro voxel data. Yeah, I've done one. I'm going to show you. Let's do something quick. I'm going to do this very quick by getting a sphere, by adding a Pyro emitter. So we have our little fire, 600 would be good. Rewind, press play. And we need to, let's say I want to create some sort of brick toy. I can't, can I say Lego? Can someone from legal please give me a call? Can I say Lego? If I can't, then I didn't say Lego. So a brick game made of Pyro. So let's go and make a brick game. And let's make each brick this. Let's make this a multi-instance. Let's space them out like that. And let's create a whole stack of these. Zonk, zonk, and zonk. There we go. I think I've got too many of them, but I don't care. So, okay. So here it is. Now, go here to the Pyro output and make sure that the various grids you want are here. So the color, I don't want temperature or velocity, just density and color. Those, I think those would suffice. Good, fantastic. And let's see if this is actually going to work. Let's go to the plane effector and let's make some of these invisible. Let's drag the Pyro output in here and make sure I have the density here. So let's see what's going to happen here. There we go. We're getting cubes, right? I can turn this off temporarily. And of course, I need to go here into the preferences, go to simulation, Pyro, all the way down, draw Pyro. There we go. So you can see now that there is something drawing. I just need to make sure that the values are, the ones I want. Linear nearest, let me see if I need to remap this, enable remapping, and usually you would go, because the values are odd, to say the least. Let's put a curve here, and let's see if we can increase the number. So yeah, I'm getting the smoke. There we go. You can see that. So I'm getting my little smoke thing. I can play with this to change it. And we have the color. Well, the color now is, what color do we have? We have, it's the default color. So let's enable this. I don't know, make it blue, I guess. And let's go. So it's going to make blue smoke. And let's see now if I take this Pyro again, plain effector. This is plain viz. And let's create another plain effector, MoGraph plain color. Go here and fields. And let's make sure that this has the Pyro output. Select this. Let's get the color. And there you go, blue. And it's mixing with everything else. So this is how you would go about it. Just use fields, drag in the field. Use effectors. In the effectors, drag the Pyro object, choose whatever you want here, and you can create your little brick game things. CG, you're using copyrighted words there. Okay. Hope this was helpful. Okay, what else we have here? Henry. I'm going to see what Henry asks. Hello, Henry. How to change the color of edge line of the object. Very hard to see when you do a weighting. Okay. Edge and line. You can change stuff, make this editable. I think, yeah, go to your preferences, Control E, go here, preferences. All the way down, you have scheme colors, interface, viewport, and so forth. All these colors, you can change them. Normal selected edge, you want them orange or something like that. The good thing is that you can always reset these colors. So selected edges, you can make them green. Haha, love that. And then you can say reset all colors. There you go. So that's how you go about changing this. Now, if you want to be able to see your vertex colors better, maybe you can change it. But can you change vertex colors? I don't know. So type here vertex. No, there is no vertex. I don't see any vertex color. Maybe you can't search here. Is there a vertex color? Vertex map. There you go. Vertex map 0% and vertex map 100%. So if you are used to a different sort of value, you can go and change these. And lastly, you can also, if you wish, you can go and you say, all right, right click. Let's put a, all right. So let's assume we have a procedural object, and you go here and you say vertex map or vertex color or whatever. And you want to do something. Of course, you can see it like that. So I'm going to go and say, okay, well, I can see this. Nice. But I want to see it when it's not selected, right? For whatever reason. Well, you create a standard material, drag it on the sphere, go in here, type C vertex, get a vertex attribute, put this directly in the surface if you wish, and go and drag this thingy-madoodle here. And it will give you the black and white values of that, and you get a pretty decent image of what you've got selected. And of course, you can go here and remap the colors as well using a ramp. Just show you ramp, drag it here. Let's go ramp, load preset. Let's do this. There you go. So you can do all these different processes here to have visualization. Okay. All right. Let's see what else. For years, question how to change the color of edge. You've been wanting what for years? Okay. Is there a way to prevent the rounding of corners with the Redshift object tag tessellation objects? I do not know. But check out what's coming up in Redshift. Am I allowed to say that? Something's coming. I don't know. I defer to Ellie's tutorials and Ellie's shows. Ask Ellie. Excellent. So we're going to wrap it up like a. How dare you use words like that? Okay. I think we're good, huh? Did I forget something? Oh, I did forget something. I think I'm going to show it next time. Good. No one else? No one else. So let me do a quick housekeeping. So now it's housekeeping. Please stick around. It won't take long. First of all, just click on this link. The more you click on these links, the more they know how much you love the show. Okay. This link will take you to this page here that thanks you for joining the live stream. And you can go to the Max and Events page, University, and other things. Also ask your questions. Now, again, I'm trying to find a solution to do this a bit more fun and a bit more interactive. And I don't know if it's going to be possible, but a way for me to share files immediately. So while you're watching the show, if I do something, I throw it somewhere and you all have access to it. That will be a wonderful thing to do. Go to the Maxon events page and check out all the cool stuff that's going on. What's Broadcast India? It's happening as we speak. It started a couple of days ago. My very good friend Jonas is there doing presentations. So if anyone's around, yeah, just go visit. Of course, we're watching this in real time. That's amazing. And all sorts of other things that are going on. Just check out that page. And don't forget that all these videos, if you don't watch them live, you can watch them live on the Maxon YouTube channel and the Maxon Training Team YouTube channel, but they're only recorded with comments and timestamps that are provided from our very good friend and mentor, Dr. Sassy. And we didn't do our little selfie, which we're going to do at the end. Let me see if this is good enough. See. Oh, you know what I'm going to do? I'm going to use the tiles, the brick tiles. So let me find, there you go, roof tiles. I think this is the one I'm going to use here. So roof tiles to do our little selfie. There we go. So let me do a little smile. And that's our photo booth moment. Let's go back to this. Maxon YouTube channel, amazing presentations from some extremely talented artists. Maxon ZBrush YouTube channel, where you can see all the amazing creations by these very talented sculptors. Yeah, go get ZBrush on your iPad and sit on your couch and pretend you work hard. Did I say that out loud? And of course, University, where we have thousands of curated tutorials that cater to your needs. More coming soon. And that's all I have to say for today. Here's my face. See anything else? Too late. How to export a blue-violet normal AOV for use in compositing to change bump strength. I think I did there's something on Cineversity. Go to, all right, let me quickly show you. I think if you go on Cineversity and you type normals, enter, look at that. It's a quick tip. Create tangent normals from any 3D scene. Can you believe that? You can learn that in 4 minutes, 22 seconds. If that's not the case, go ask the question on the forum. Use that link pasted above. That's it. Anything else? That's all I have for today. Let's put my face here. Once again, it was a pleasure and an honor hanging out with you. Let me know on various socials. Go on Twitter and find me at NosemanGR. I usually answer my DMs, although I think there's something fishy going on with the DMs lately. Although I did receive some, so I don't know how fishy it is. But in any case, just make sure you subscribe and you comment and do all those things everyone needs to do on social mediums to get a few more eyes on us. Take care, everyone. See you soon. Bye-bye. I need to press some buttons. So the show has ended now. This is the unofficial. It always happens. I say bye-bye, and I forget that I need to put on some sort of end video. Yeah, there you go. And there's a QR code. Go click on it at your own peril.